So suppose we begin with a neutral atom, in which the number of electrons equals number of protons. Now what that basically means is that if we add up our charges due to our electrons with the charges due to our protons, we're going to get a net charge or an overall charge of 0. Now that's exactly what a neutral atom is. It's an atom in which our charge is 0. Well, now suppose we take our atom and our neutral atom gains or loses electrons. Well, now we have a case in which the number of electrons is no longer equal to the number of protons, and so we're going to get a charged species called an ion. Now whenever we're dealing with metals, be it transition metals, alkaline metals, or alkaline earth metals, these guys tend to lose electrons because they can't hold on to the electrons very tightly. They're not very electronegative. And what that basically means is that they will form ions with positive charges. And these guys are called cations. Now on the contrary, nonmetals such as the halogens or oxygen or sulfur, these guys have a very high affinity for electrons. And that means they will tend to take away electrons from other less electronegative atoms. And that means they will form ions in which there is a negative charge. And these guys are called anions. Now let's look at the following illustration. Suppose we have a neutral atom X, and this guy takes away an electron from some other atom, forming an anion. Well, this guy will simply have a negative charge represented in the following way. Now, most nonmetals follow this pathway. Now suppose we have the reverse. Suppose we have an atom X that loses an electron, or loses an electron. Now this guy will form a cation, or an ion with a positive charge. Now most metals follow this pathway. Now one note about transition metals. Transition metals, whenever they lose electrons, they first lose electrons from the s orbital, and then from the d orbital. And that's because the s orbital is at a higher state than the d orbital. And electrons lose, or electrons leave, the higher levels first before the lower levels. Now we're going to talk more about orbitals, the s orbitals and d orbitals in a future lecture, so stick around. Now, what happens to the size of our atom when it loses or gains an electron? Well, let's suppose we have a neutral atom that has 2 protons and 2 electrons. And let's look at our illustration. So, 1 electron on the outermost shell, 1 electron on the innermost shell, and 2 plus or 2 protons found in our nucleus. So its charge is 0. Now suppose it loses an electron. Let's say it loses our outermost electron. Well, that means it's going to shrink in size, and this is why. Remember, most atoms are generally composed of empty space. So when this guy disappears, all this empty space goes with it, and so it becomes much smaller. So now the +2 charge will be greater than our -1 charge, and that means this electron will be pulled even closer to the nucleus, decreasing in size even further. So, when we're talking about cations, or when neutral atoms become cations, there is a loss of electron, and this shrinks the element to a smaller size. Now, on the contrary, let's look at anions. So what happens to anions? Suppose now we have a neutral atom with a +1 charge and a -1 charge, forming a neutral charge. And now suppose it gains an electron from some other atom, probably metal. Now what will happen is it will gain a new outer shell, forming this outer shell and forming this empty space in between. And that means anions, when they gain electrons, this causes our atom or element to grow in size. So cations, or the formation of cations, decrease the size of our atom, while the formation of anions increases the size of our atom. Now let's look at one last thing. Now isoelectronic atoms are those atoms that have the same number of electrons but different number of protons. Suppose we have an atom with 10 electrons and 10 protons, and an atom with 10 electrons and 11 protons. Now what is the size comparison? Well, the atom with more positive charge, with the 11 protons, the nucleus will be able to pull the electrons closer than the other atom that has only 10 protons. And that means when we're talking about isoelectronic atoms that have the same number of electrons, when there's an increase in the number of protons, our atom tends to become smaller.